Have you ever wondered how the future of imaging might look? Could the concept of Star Wars-like holograms become a reality? We will introduce the fascinating world of holography, an intriguing realm where science meets art and reality is redefined. Holography, a revolutionary technique that captures light field in a way traditional photography can't, holds the potential to transform the future of imaging. It's like capturing a slice of the universe and viewing it from any angle you want. Imagine being able to interact with three-dimensional images floating in mid-air, just like in your favorite sci-fi movies. From enhancing security measures to revolutionizing entertainment and media, holography is poised to impact various facets of our lives. But how does it work? What makes it so unique and powerful? Let's dive into the captivating world of holography and explore its endless possibilities. Let's unravel the enigma of holography, where light, science, and imagination intertwine to create a mesmerizing spectacle. To understand the future, we must first delve into the past. So, let's time travel back to the mid-20th century. The concept of holography was first introduced to the world by a British-Hungarian physicist named Gabor. Striving to improve the resolution of electron microscopes, Gabor coined the term holography, combining the Greek words holos, meaning whole, and graphe, meaning writing or drawing. In contrast to traditional photography, which captures a two-dimensional representation of a scene, a holograph creates a three-dimensional image. It's like stepping into a scene from a sci-fi movie, where a three-dimensional image pops up from a flat surface, floating in mid-air, tangible yet intangible. The breakthrough came in the 1960s when lasers were invented. The coherent light emitted by lasers was the missing piece in Gabor's holography puzzle. This technological leap paved the way for Emmett Leith and Juris Upatnieks at the University of Michigan to create the first laser-based hologram. Over the years, holography has evolved and branched into various subfields, such as digital holography and computer-generated holography. Each branch has its own unique applications, from art and entertainment to scientific research and even security. But what truly differentiates holography from traditional photography is the way it captures light. A photograph records the intensity of light reflected off objects, but a hologram goes a step further. It records both the intensity and the phase of light waves, capturing the interference pattern created by the interaction between the object beam and the reference beam. This intricate dance of light waves gives us a complete picture of the scene, with depth and parallax, creating a more lifelike and immersive viewing experience. The ability to record and reconstruct a three-dimensional scene onto a two-dimensional surface is nothing short of magic. Yet, it's not magic. It's physics. It's optics. It's the science of holography. Now that we've explored the roots of holography, let's uncover how it actually works. Holography isn't magic, it's pure science. Indeed, the creation of a hologram is a fascinating process that involves several scientific principles, primarily light interference, diffraction, coherence, and the crucial role of lasers. Let's start with light interference. Light waves are similar to ripples in a pond. When two sets of ripples intersect, they create a new pattern. This is essentially what happens in light interference. When two light waves meet, they create a new pattern based on their respective phases. A hologram captures this pattern of interference, creating a snapshot of the light field, not just an image. Next up is diffraction. This is the bending of light as it passes around an object or through a narrow aperture. A holographic recording involves diffracted light, which spreads out and creates an interference pattern with the reference light from a laser. This interference pattern, when viewed under the same laser light, recreates the original light field, bringing the holographic image to life. Now, onto coherence. For a successful holographic recording, the light source needs to have a high degree of coherence, meaning the light waves are in phase with each other. The light from a laser is highly coherent, making lasers the ideal light source for holography. Creating a hologram is both an art and a science. With the right blend of technology, precision, and creativity, we can design a three-dimensional image that seems to float in thin air. The process of creating a hologram begins with a laser beam. This beam is split into two, One, the reference beam, is directed towards the recording medium, while the other, the object beam, is bounced off the object we want to capture. The interference pattern between these two beams, captured on the recording medium, forms the heart of the hologram. But not all holograms are created equal. Transmission holograms, for instance, are viewed with laser light, usually of the same type used to make the recording. When this light meets the hologram, it is bent and focuses on the original subject's position. Reflection holograms, on the other hand, are designed to be viewed in white light, creating a rainbow effect. This happens as the light waves of different lengths or colors are bent at slightly different angles, causing the colors to spread out and form a spectrum. Then there are computer-generated holograms, a product of advanced computational methods. These types of holograms are created directly from digital data, without the need for a physical object. The behavior of light is key to understanding holography. Unlike a regular photograph, a hologram records an image as a set of interference patterns, capturing the phase and amplitude of light waves. This is what gives a hologram its unique three-dimensional quality. When viewed, light from the hologram reconstructs the wavefront of light reflected from the object, creating a virtual image of the object. This image changes as the position and orientation of the viewing system changes in exactly the same way as if the object were still present, giving the image a three-dimensional depth. So, from safeguarding our banknotes and passports to adding an extra layer of realism to our favorite movies and concerts, the art of making holograms is indeed an exciting blend of science and creativity. From security to entertainment, holography has found its way into various fields. And with constant advancements, the possibilities are truly endless. Holography isn't limited to a science lab, it's all around us. Let's delve into the world where holography is more than just a fascinating concept, but a real functional tool. In the realm of security, holography is a silent guardian. It protects our banknotes and passports from forgery, with intricate holographic designs that are challenging to replicate. This is a testament to the unique ability of holography to capture complex information in a way traditional imaging methods cannot. Holography also brings an extra dimension to the world of art. Artists manipulate light, space, and perception to create captivating three-dimensional images. These holographic artworks challenge our sense of reality, pushing the boundaries of what is visually possible. Education, too, benefits from holography. It transforms learning into an interactive, immersive experience. Complex concepts in science, technology, engineering, and mathematics become tangible, fostering a deeper understanding. Meanwhile, in the healthcare sector, holography is revolutionizing medical imaging. Holographic microscopy and tomography allow for non-invasive, detailed examination of tissues and organs. This not only improves diagnostic accuracy, but also aids in planning and executing surgical procedures. In the military, holographic sights have become standard equipment. By superimposing a reticle onto the target view, they provide improved accuracy and situational awareness. This technology is also finding its way into civilian applications, enhancing our gaming and sporting experiences. The entertainment and media industry is perhaps where holography truly shines. Holographic displays have brought deceased musicians back to the concert stage, blurring the line between reality and illusion. Augmented reality and virtual reality experiences, powered by holography, transport us to worlds beyond our imagination. And let's not forget data storage. Holography allows for high-density, three-dimensional data storage, opening up possibilities for handling the ever-increasing volume of digital information in our world. The applications of holography are vast, but what does the future hold? As we continue to explore and innovate, the potential for holography is boundless. The only limit is our imagination. So let's keep asking questions, keep exploring, and see where this incredible journey of light leads us. The realm of imaging is set for a revolution, thanks to holography. Imagine being able to touch and interact with a projected image, as if it were right in front of you. Holography is on the brink of making this a reality. Potential future applications of holography span across diverse fields. In the medical sector, holographic imaging could drastically improve diagnostics and surgical precision. Holographic telepresence could redefine communication, enabling people to interact with life-size, three-dimensional representations of each other, irrespective of their geographical locations. In entertainment, imagine watching a football match where the players appear to be running around on your coffee table, or a concert where you can see the performer from all angles, as if you were there in person. These experiences could be brought to life with advanced holographic displays that don't require the use of special glasses. The integration of holography with artificial intelligence and machine learning could pave the way for real-time data visualization, enhancing our understanding of complex information. However, this journey towards a holographic future is not without its challenges. Current technical limitations, such as the need for high-quality lasers and recording media, require further advancements. The cost of holographic technology is another hurdle that needs to be addressed. But the most significant challenge lies in our ability to compute and process vast amounts of data quickly enough to create real-time, interactive holograms. Yet, the field of holography is evolving rapidly. Innovations in materials and laser technology, coupled with advancements in computational methods, are bringing us closer to overcoming these obstacles. The development of more compact, efficient lasers and the exploration of new recording mediums are significant strides in this direction. The future of holography is bright and holds promise for a new era of imaging, a world where we can touch, interact with, and manipulate images in a way we never thought possible. As we stand on the cusp of this new frontier, we can't help but be excited about the endless possibilities that holography will bring. Holography is constantly evolving, with new frontiers being explored. One such frontier is quantum holography, a remarkable blend of quantum mechanics and holography. Quantum holography delves into the realm of the very small, harnessing quantum properties to store and process information. This intriguing field has the potential to revolutionize quantum computing and information storage, opening up a world of possibilities that were once confined to the realm of science fiction. Digital holography, on the other hand, brings the world of holography into the digital age. Instead of using photographic plates, digital holography employs digital sensors to record the interference pattern. This digital information can then be processed by a computer to produce a three-dimensional image. The advantage? Digital holography allows for the manipulation and enhancement of images after they have been recorded, offering unprecedented control over the final image. But the advancements don't stop there. Computational techniques are playing an increasingly important role in holography. These techniques allow for the reconstruction of holograms using numerical methods, enabling the creation of complex and detailed holographic images. One such method is phase retrieval, a computational technique that recovers the lost phase information in a hologram to produce an accurate three-dimensional image. Moreover, computational techniques are also crucial in the development of computer-generated holography. Here, the interference pattern is not recorded from a physical scene, but is instead calculated using complex algorithms. This opens the door to creating holographic images of objects that don't physically exist, expanding the scope of holography beyond our physical world. As we've seen, holography is a constantly evolving field, merging with other technologies to create fascinating possibilities. From quantum holography's potential in quantum computing to the flexibility offered by digital and computational holography, the science of holography is pushing the boundaries of what we thought was possible. As we continue to explore these advanced principles, who knows what the future of holography will bring? Holography is more than just a sci-fi fantasy. This statement captures the essence of our journey through the world of holography. We've explored how this intriguing technology, born from the principles of light interference and diffraction, has evolved from its inception to the present day. We've seen how the intricate process of creating holograms opens up a world of possibilities, each unique in its own way, from transmission to rainbow to computer-generated holograms. Holography's applications are as diverse as they are fascinating, whether it's enhancing security in our passports and banknotes, revolutionizing medical imaging, or creating unforgettable entertainment experiences. Holography is making its mark, and it's not stopping there. The future holds even more promise, with advancements in materials, laser technology, and computational methods paving the way for innovations like holographic telepresence and advanced holographic displays. But as with any technology, the road to innovation is not without its challenges. The need for further research and development, the cost of implementation, and the technical obstacles are all factors that need to be considered. Yet it's these challenges that fuel the desire for progress and inspire the advancements that propel us forward. We've also delved into the complex world of quantum holography, exploring the potential it holds for quantum computing and information storage. And let's not forget the role of digital sensors and computers in recording and reconstructing holograms, or the evolution of laser technology and the properties of the materials used for holography. All these components work together to form the intricate puzzle that is holography. And where does this leave us? At the cusp of a revolution. A revolution in how we perceive and interact with the world around us. A revolution in how we store and process information. A revolution in how we entertain, educate, and communicate. The future of imaging is exciting, and holography is set to play a pivotal role in shaping it. The question is, are we ready to embrace this revolution?